Hello guys, welcome in today's session. I am Professor Fayyaz Karadi from Department of Mechanical Engineering. This is our module number 1.5, chip thickness ratio and shear plane angle. In this module, we are going to study what is chip thickness ratio and shear plane angle and what is the relationship between them by studying one simple derivation between them from unit number 1, theory of metal cutting from manufacturing process to subject. So let us start. First of all, chip thickness ratio, which is denoted by small alphabet r. This is also called as cutting ratio in some books. So chip thickness ratio is the ratio of thickness of metal before cutting to the thickness of metal after cutting. That is chip thickness. So in this figure, you can see the tool apply the force on the workpiece material. This is workpiece material and this is tool. And the awake angle of tool is denoted by here alpha letter. So when the tool advances into the workpiece, the material in front of the tool is get deformed, which is removed from the workpiece material in form of chip. So here you can see that T1, which is denoted here uncut chip thickness. T1 is nothing but uncut chip thickness or thickness of material before cutting. T1 in lathe machine, that T1 is again you can say as depth of cut. In turning operation, that T1, the material before cutting, you can also say that this is depth of cut, where T2 is thickness of material after cutting or thickness of chip. T2 also called as deformed chip thickness. So mathematically, as per the definition of chip thickness ratio, you can say that chip thickness ratio R is equal to T1 divided by T2. A ratio of thickness of material before cutting divided by thickness of material after cutting, that is chip thickness. So chip thickness ratio R is equal to T1 divided by T2. So let us see the questions may ask in the examination or your gate exam also. What will be the value of R? The option is R is greater than or equal to 1. Second, R is less than or equal to 1. So what will be your answer? You can see in this image the thickness after cutting, that is chip thickness, is always greater than the T1. T2 is always greater than T1 due to the deformation of material by the tool offering the force or pressure on the workpiece material. So due to the force or deformation, the material get deformed and the thickness of chip is increased while cutting. So T2, value of T2 is always greater than T1. The thickness after cutting always greater than before cutting or chip thickness. So T2 is greater than T1. So chip thickness ratio is always less than 1. That will be your answer. The chip thickness ratio, the value of chip thickness ratio is always less than 1. Why? Because the thickness of material after cutting is always greater than before cutting. Now, opposite to this chip thickness ratio is chip reduction ratio or chip reduction coefficient, which is denoted by small letter k, small alphabet k, is equal to a reciprocal of chip thickness ratio. Chip reduction ratio is a reciprocal of chip thickness ratio 1 by r. So k is equal to T2 divided by T1. So when T2 is greater than T1, at that time the value of the reciprocal k is always greater than 1. So the chip thickness ratio is always less than 1, whereas chip reduction ratio is always greater than 1. Now come to the next definition, shear plane angle, which is denoted by phi. First of all, see what is shear plane. The metal in front of the tool get compressed. This is tool, and the material in front of tool is, you can see, in form of chip. This is get compressed, causing shear stress, which is maximum along a plane called shear plane. So you can see in other, you can say in other word, the plane at which you will find the maximum shear, that plane is called shear plane. And this plane is the interface of material, workpiece material and chip. Interface between chip and workpiece material, shear plane. And shear plane angle phi is nothing but the angle made by shear plane with the direction of tool movement is called shear plane angle. The angle made by shear plane and the line parallel to the direction of tool motion. This is tool, and this tool is moving from right to left in this figure. So this horizontal line is nothing but direction of tool movement. So the angle made by shear plane and this horizontal line is called as shear plane angle, and this is denoted by phi. So the chip flow velocity is affected by shear plane angle due to variation of phi. The chip flow velocity, the velocity of chip flow is affected by the value of phi. Okay. Now come to the derivation point here. The figure is in front of you. This is tool, and this tool having the angle with the vertical line is alpha, which is a rake angle of tool. Here it is written here, alpha is a rake angle of tool. Okay, the AB line denoted as shear plane, and shear plane is phi with this horizontal line. Okay, the thickness before cutting is T1 and thickness of chip after cutting is T2, chip thickness. Okay, now what I do here, I draw the perpendicular line from point B, which is intersecting to this horizontal line at point C. So that BC line is perpendicular to this horizontal line, which is making the triangle here as ABC. ABC. In this triangle, the angle BAC is phi, which is shear plane angle. Okay, this is 90-degree angle, so this will become 90 minus phi. Okay, now I draw the same construction line as BD, which is perpendicular to this tool face, perpendicular to this tool face, or the interface between chip and tool. So this line is chip tool interface line. Okay, so this BD line is perpendicular to this chip tool interface line. So the angle BDA is again a perpendicular, and this triangle BAD is again a a right angle triangle here. In this both the angle, the line AB is common in both the triangle. So I will find the length of AB, the value of AB from this triangle ABC in terms of T1. And the second step I will do here, I will find the length of AB from triangle ABD in terms of T2. Okay, so I will find two equation and I will compare. In that both the equation, the AB is common, so I will find the value of AB and I will compare both the equations. So let us start from triangle ABC. Okay, consider this triangle ABC. In that triangle, this angle will be phi. So and I know the length of BC as T1. So I will take that sine rule. Sine phi is equal to opposite side BC divided by hypotenuse AB. So what is the value of BC? That is nothing but T1. So putting the value of BC as T1, sine phi is equal to T1 divided by AB. So I find the value of AB here. AB is equal to T1 divided by sine phi. This will become my equation number 1. AB is equal to T1 divided by sine phi. Remember this. AB is equal to T1 divided by sine phi from this triangle. Now come to this triangle ABD. This triangle ABD. In this triangle, I will find the value of the angle BAD. The angle BAD. So I will consider here. I know this angle, this horizontal line. I will draw here horizontal line. This inclination AB. This inclination AB. This angle is phi. This angle is phi, and again I will draw the perpendicular line to AC is this perpendicular line AC A and this perpendicular line, and I know this angle alpha, so I have to find this angle. So this is complete 90-degree angle. This is complete 90-degree angle. This angle I know phi, so remaining angle is will be 90 minus phi. Due to this vertical line to this line, this angle will be complete angle will be 90. So remaining angle will be 90 minus phi, and this angle will be a rake angle of tool with this vertical line which is alpha. So this total angle from this line to this line, this total angle will become here 90 minus phi plus alpha. 90 minus phi plus alpha. So this angle BAD, this will be 90 minus phi plus alpha. Okay, now let us start to find this angle ABD. This angle I know now, 90 minus phi plus alpha. Now I am going to find ABD. So I know that the addition of all three angles in right angle triangle will be 180 degree. This I know, and that I learned in my school. So addition of all three angle is 180 degree. I know this angle. This is 90 degree. BDA is 90 degree. So third angle will be, I will consider as X, which I have to find out. 90 minus phi plus alpha, this angle. Here I found it here. 90 minus phi plus alpha, this one angle. Second, 90 degree. This is 90 degree angle. 90 plus this I will consider as X, which I don't know, equal to 180 degree. So this 90 will be 180 minus phi plus alpha. plus x is equal to 180. This 180 will cancel this 180. So x is equal to this minus 5. When this move to right side, this will become 5 plus 5, and this plus will change to minus alpha. So x will be 5 minus alpha. So this angle will be angle ABD. Angle ABD will become here 5 minus alpha. 5 minus alpha. So I will find the cos rule for this angle. I will apply the cos rule from this triangle ABD. Now come to the triangle ABD. Consider this triangle ABD to find the value of AB. Okay, ABD cos 5 minus alpha. This cos, this is right angle triangle. So AB will become hypotenuse and BD will become adjacent side. So cos 5 minus alpha is equal to adjacent side BD divided by hypotenuse AB. So this BD is nothing but T2, thickness of chip after cutting T2. Cos 5 minus alpha is equal to T2 divided by AB. T2 divided by AB. So value of AB will become here T2 divided by cos 5 minus alpha. This will become equation number 2. So I got the value of AB in two equations 1 and 2. So I compare that two equation 1 and 2. This will become T1 divided by sin phi is equal to T2 divided by cos phi minus alpha. Okay, so I will move that T2 to left side. It will become T1 divided by T2 is equal to sin phi divided by cos phi minus alpha. T1 divided by T2 is equal to sin phi divided by cos phi minus alpha. I know the value of T1 divided by T2. What is T1 divided by T2? That is chip thickness ratio R. Chip thickness ratio is R. Okay, and I learned the formula cos A minus B. Cos A minus B. What is cos A minus B? Cos A cos B plus sin A sin B from trigonometry. Cos A minus B is equal to cos A cos B plus sin A sin B. I will write here in next step R is equal to, this is chip thickness ratio T1 divided by T2. R is equal to sin phi divided by cos A cos B is cos phi cos alpha plus sin A sin B sin phi into sin alpha. Cos phi cos alpha plus sin phi sin alpha. Okay, now the next step is divide by cos phi to numerator and denominator. Divide by cos phi. So sin phi divided by cos phi, this will become tan phi. This term will become here tan phi. I is equal to tan phi divided by cos phi cos alpha divided by cos phi. So this cos phi and cos phi will get cancelled. Remaining term will be cos alpha plus sin phi divided by cos phi will become tan phi, and remaining term will be sin alpha. Tan phi sin alpha. So I will take the cos. After simplifying this equation, I will get here I cross multiply here r cos alpha plus r tan phi sin alpha. R cos alpha plus r tan phi sin alpha is equal to tan phi. This remaining tan phi to right side. So r cos alpha is equal to, I will make this term, I will move that term towards right of the equation. So r cos alpha is equal to tan phi minus r tan phi sin alpha. And in next step, r cos alpha, I will take tan phi as a common term. So tan phi is tan phi into this 1 minus r sin alpha. R sin alpha by taking tan phi as common. So after solving this, tan phi, so this will keep as it is, and this 1 minus r sin phi I will move towards left. So it will become r cos alpha divided by 1 minus r sin alpha is equal to tan phi. So tan phi is equal to r cos alpha divided by 1 minus r sin alpha. This will become the relation between the shear plane angle phi and chip thickness ratio. Chip thickness ratio. So this will our final expression is tan phi is equal to r cos alpha divided by r sin alpha. This expression may come in the examination for 6 marks, or you have to remember that formula for solving the numericals. Okay, so the value of shear plane angle is the function of tool geometry. That tool geometry is nothing but a rake angle of tool is alpha. Tool material and workpiece material which directly affect that chip thickness ratio R. Okay, so shear plane angle is the function of tool material and workpiece material and tool geometry. Okay, so remember this formula: tan phi is equal to r cos alpha divided by 1 minus r sin alpha. Tan phi is equal to r cos alpha divided by 1 minus r sin alpha. Okay, so if the value of shear angle is large, the shear plane will be shorter, the chip is thinner, and hence small amount of force will be required to remove the chip. Okay, so remember that if the value of shear angle is large, the shear plane will be shorter, the chip is thinner, and hence small amount of force will be required to remove the chip. So the motor which is used in the machine will be of less capacity. So at the end of this session, the student can understood the chip thickness ratio and shear plane angle and the relation between them, that you have to remember as a derivation part in the examination, and to find to solve the numericals in further module. So thank you for attending this video.